Okay, welcome to Math 158, Functions, Graphs, and Matrices. This is section 4.3. We're going to look at a few application problems on systems of linear equations. Throughout this video, this lesson, the method of solution I'm going to use primarily is going to be using the augmented matrices that we learned in the previous video, previous section 4.2, using the graphing calculator. Okay, so that's going to be the simplest way to handle some of these. Some people might choose to use the elimination method. But I'm pretty much going to try to reinforce using the graphing calculator in augmented matrices. So let's look at the first problem here. The Arctic Juice Company makes 3 juice blends. They make a pine orange blend using 2 quarts of pineapple juice, 2 quarts of orange juice. The Arctic Juice Company makes 3 juice blends. They make a pine orange, which uses 2 quarts of pineapple juice and 2 quarts of orange juice per gallon. The pine kiwi uses 3 quarts of pineapple juice and 1 quart of kiwi juice per gallon. And the orange kiwi uses 3 quarts of orange juice and 1 quart of kiwi juice per gallon. Each day, the company has 800 quarts of pineapple juice, 650 quarts of orange juice, and 350 quarts of kiwi juice available. How many gallons of each blend should it make each day if it wants to use up all of the supplies? I'm going to set up a table. Okay, we're going to have some equations, we're going to have some variables. The first thing to decide is which is which. What is going to be representing an equation, what's going to represent the variable. So you notice that we have juice. We've got pineapple juice, we've got orange juice, we've got kiwi juice. We also have the blends, the pine orange blend, the pine kiwi blend, and the orange kiwi blend. So the blends will either be the equations or the variables. The juices will either be the variable or the equations. How do I know which is which? Here's a big clue. The company has 800 quarts of pineapple juice, 650 quarts of orange juice, 350 quarts of kiwi juice. Since I know the total amounts of pineapple, orange, and kiwi juice, those are probably going to be equations. Also, how many gallons of each blend should the company make each day if it wants to use up all the supplies? How many gallons of each blend? It seems to indicate how much pine orange blend, how much pine kiwi blend is what I'm trying to solve for. Those are probably the variables. Okay, so I can set up a table, I can set up a concept, right? We've got pineapple juice, we have orange juice, and we have kiwi juice. We have the pine orange blend, the pine kiwi blend, and the orange kiwi blend. Okay, let's make a little table here. The pine orange uses 2 quarts of pineapple juice and 2 quarts of orange juice. The pine kiwi will use 3 quarts of pineapple juice and 1 quart of kiwi juice. The orange kiwi will use 3 quarts of orange juice and 1 quart of kiwi juice per blend. Each day, the company has 800 quarts total of pineapple juice, 650 quarts of orange juice, and 350 quarts of kiwi juice. Now, I'm going to let pine orange be my X, pine kiwi be Y, and orange kiwi be Z. So notice 2x plus 3y, 2x plus 3z, and 1y plus 1z. So 2x plus 3y is equal to 800. 2x plus 3z is equal to 650. And 1y plus 1z is equal to 350. And there's my system. I can write an augmented matrix, 2, 3, 0, 800. Don't forget the zeros. 2, 0, 3, 650, and 0, 1, 1, 350. Right, because there's 0z here, and there's 0y here, and there's 0x here. So don't forget, that's not an x, don't forget to put those zeros into your matrix. Okay, so those are necessary. So remember, second matrix, edit our augmented matrix. Whoops. Matrix A is the one I wanted to use. Our matrix is a 3 by 4 matrix. 2, 3, 0, 800. 2, 0, 3, 650. 0, 1, 1, 350. We have those things entered. Let's quit. Second matrix, math. Remember that we want option B, reduced row echelon form, and we want to do that on matrix A. Enter. So notice that we have 1, 0, 0, 0, 1, 0, 0, 0, 1, and then 100, 200, and 150. And if you recall, this means that x equals 100, y equals 200, and z equals 150. But again, remember that x, y, and z represent how many of each blend. So what this means is I'm going to make 100. Now that's going to be quarts actually, right? How many gallons of each blend should it make, right? X is the number of quarts because we've got 800 quarts. So there's another thing to keep in mind. That's 800 quarts of the pine orange blend, 200 quarts of the pine kiwi blend, and 150 quarts of the orange kiwi blend. In order to change those to gallons, I'm going to have to divide by 4. So 25 gallons of the pine orange, 50 gallons of the pine kiwi, and 37.5 gallons of the orange kiwi. Okay, so you want to keep those in mind. Right? So not so bad once I get the system set up. That's the trick. Okay, example 2. A new airline has recently purchased a fleet of Airbus A330-300s, Boeing 767-300ERs, and Boeing Dreamliner 787-9s to meet an estimated demand for 5,400 seats. Now, here's a problem that we're going to deal with: is each one of these airplanes not only have a number, not only have a name, but they also have a number. Okay, I'm going to refer to them as the Airbus, the Boeing, and the Dreamliner. Even though the Dreamliner is made by Boeing, I'm just going to call it the Dreamliner. And this Boeing 67, I'm just going to call it Boeing. That way, I don't need to keep saying all these numbers. Okay. Now, before I keep going, well, let's just keep. Let's keep going. The Airbus seats 330 passengers, and they cost $250 million each. The Boeings seat 270 passengers and cost $200 million each, while the Dreamliners seat 240 passengers and cost $250 million each. The total cost of the fleet, we'll come back to this part, which had twice as many Dreamliners as Boeings, was $4,750,000. Yeah. $4,750,000,000. Okay. How many of each type of aircraft did the company purchase? The company, what I'm going to use A, B, and D. Airbus, Boeing, Dreamliner, to try to simplify this. Now the Airbus, remember, it says that it will seat 330 passengers. The Boeing will seat 270 passengers. And then the Dreamliner will seat 240 passengers. So if I have 330 passengers per Airbus, 270 passengers per Boeing, and 240 passengers per Dreamliner, and we have a demand of 54,000 seats for 5,400 seats for our passengers, there's the number of seats available. Okay. Now let's talk about the cost. The Airbus will cost $250 million each. That's $250 million per Airbus. The Boeing will cost $200 million. So that's $200 million per Boeing. And the Dreamliners cost $250. So that's $250 million per Dreamliner. And it says the total cost of the fleet was $4,750 million, which is $4,750,000. So notice we have two equations with two unknowns. The last piece, we need a third equation. The last piece of information here, it says that the fleet had twice as many Boeings as Dreamliners. So we've got Boeing, we have Dreamliners. There are twice as many Boeings as Dreamliners. I like to do this. There are 10 Boeings, there would be 5 Dreamliners because there's twice as many Boeings as there are Dreamliners. That means I'm going to multiply the Dreamliners by 2. The number of Boeings is equal to twice the number of Dreamliners. So B minus 2D equals 0, and there's my third equation. I'm going to speed this up a little bit. I'm not even going to bother to write this as the augmented matrix. I'm going to go right to my calculator. Second matrix, edit, matrix A. If I wrote this as an augmented matrix, it would be a 3 by 4 because notice that there are 3 rows and there would be 4 columns. 330, 270, 240, and 5,400. 250, 200, 250, 4,750. 0, 1, -2, and 0. Second quit. I showed this in the previous video. Remember, with the calculator, if you simply press enter, the calculator will repeat the previous command. And it looks to me like I made a mistake. What makes me think I made a mistake here is the fact that we got decimals here. Okay, so this tells me I made a mistake. So let's go back in and say, where did I make my mistake? Okay, what I notice here, twice as many 787s as 767s. The 787s are the Dreamliners and the 767 are the Boeings. So I kind of had all of this backward, which is probably not a good thing to do to you here. But so there are twice as many Dreamliners as there are Boeings. So if there's 10 Dreamliners, there's 5 Boeings. So I need to double the number of Boeings. Okay. So I wanted to do that to show you how you would recognize if you made a mistake or not. I've said this in previous videos that you really have to be prepared to get decimals or fractions. But we are here talking about the number of airplanes. You cannot have a fractional number of airplanes. That would not be very safe, right? So we do know that since we're talking about the number of airplanes, they should come out to be integers. So let's try to fix this third equation, right? So notice that D is equal to 2B. So 2B minus D would equal 0. So there's a good clue there that you can use to help you know if you actually subtracted these backward, because this is often going to happen. Second matrix. So I need to go back to this matrix, and I don't need to fix everything. I just need to keep this A value at 0. This is now 2B and a -1D, and that stays as a 0. And again, repeat that previous command by simply pressing enter. And you'll notice that the Airbus, we need 5 of those. The 767s, we need 5 of those. And the 787s, we would need 10 of those. And then that situation will meet our demand. Okay? Let's do a couple more. The enormous State University History Department offers 3 courses: Ancient, Medieval, and Modern History. The chairperson is trying to decide how many sections of each to offer this semester. Now, rather than using A and B and whatever, because we have an AMM, I'm going to say that the ancient history is X, medieval history is Y, and modern history is Z. Notice I write these down. It's a very good thing to do. The chairperson is trying to decide how many sections of each to offer this semester. The department is allowed to offer 45 sections total. That means the number of sections of ancient history plus the number of sections of medieval history plus the number of sections of modern history would need to equal 45 sections. Keep reading. There are 5,000 students who would like to take the course, and there are 60 professors to teach them. Sections of ancient history will have 100 students per section. Medieval can hold 50 students per section, and modern history will allow 200 students per section. And again, how many students total? There's a total of 5,000 students. Modern history sections are taught by a team of 2 professors. Ancient and medieval history only need 1 professor. So I only need 1 professor for each section of ancient history, 1 professor for each section of medieval history, but I need 2 professors for each section of modern history. And I have a total of 60 professors. So notice there are my 3 equations. And if you look at these equations, the first equation is the number of sections. The second equation is the number of students. And the third equation is the number of professors. There should be a commonality to each of these. Okay? So since I've learned how to solve systems using augmented matrices, and especially on my graphing calculator, you'll notice quite a bit of repetition, right? So second matrix, and now we're going to change this to the 3x4 matrix. 1, 1, 1, 45, 100, 50, 200, 5,000. 1, 1, 2, 60. Second quit. Our REF matrix A will repeat the previous command. And so ancient, we need 10 sections. Medieval, we need 20 sections. And modern, 15 sections. And if we offer 10 sections of ancient history, 20 sections of medieval history, and 15 sections of modern history, given those constraints, we can accommodate all of our students with the professors that we have available. Okay. All right. Problem number 4, example 4. I'm going to, for sake of time in this video, I'm going to skip this problem. It gets into a little bit more complexity than I want to in this video. Okay. If we're meeting personally in class, we would go through it. For the purposes of this video, and for what I'm going to hold you accountable for, we're just going to go right on to example 5. Okay. Let's look at example 5. An investor has $5,000 to invest in 3 different accounts. One is a low risk, one is a medium risk, and the third is a high risk. Now, I'll be honest with you, I'm tempted to use the letters L, M, and W. I'm sorry, L, M, and H. L for low, M for medium, and H for high for each of my investments. The problem I have with that is that if I use L as a variable, I don't write L's very well, and L's can be confused with 1s. So I'm just going to stick with the low. I'm going to use X. Medium, I'm going to use Y. And a high risk investment, I'm going to use Z. Okay. You've noticed I don't write super well anyway, so I try to be careful not to confuse myself too much. Okay. The investor has $5,000 to invest. Notice the question at the end is going to be how much money should be invested in each of the 3 accounts. So the number of dollars I invest in the low risk plus the dollars invested in the high risk plus the dollars invested in the high risk should be a total of $5,000 invested. I'm expecting to earn 5.2% interest on my low risk account. So 0.052 times the number of dollars invested. I'm expecting to earn 6.7% interest on the medium risk. So I'm going to multiply my Y dollars by 0.067. My high risk is expected to earn 10.3% interest, and she anticipates she wants to earn 8% on the total investment. So that's going to be 8% on the total investment of $5,000. Also, due to her age, the investor is willing to invest twice as much money in the high as in the low risk account. So here's the high risk and here's the low risk. She's willing to put twice as much money in the high risk. So for every $2 in the high risk, she's only going to put $1 in the low risk. To set those equal to each other, you would have to multiply the x by 2. So this third equation will become 2x minus z equals 0. And there are my three equations. One of the beautiful things about using the graphing calculator in the augmented matrices, I'm not sweating at all the decimals of 0.052, 0.067, 0.103. And I'd love to show you all the arithmetic ways that you can handle that. But I'm going to show you this for now instead. Matrix. And again, 3 rows, 4 columns, 3 by 4 matrix. 1x, 1y, 1z, 5,000. 0.052x, 0.067y, 0.103z. Now you ready? 0.08 times 5,000. The calculator will handle this perfectly for us. It's 400. 2x, 0y, negative 1z, 0. Now, remember that at the very beginning, that first problem, right? The number of airplanes that I'm buying or whatever, that it needs to be an integer. Here, money doesn't necessarily have to be an integer, so I'm going to need to be super careful, especially with this third equation, to make sure that I got it correctly. So before I go too much farther, let's just double check that. She's willing to invest twice as much money in the high risk account as in the low risk. And did she? Z is high. Twice as much, $2, $1. So Z, the dollars in Z, is twice X. That looks right. Second quit. Enter to repeat the previous command. Now I'm a little concerned because I'm getting dollar amounts that are not exactly integers, but they don't have to be, right? So the low risk account, she's going to invest $1,140.35. In the medium risk account, she's going to invest $1,578.95. And in the high risk account, she's going to invest $2,280.70. So the other thing I'm going to do to confirm that I have set this up correctly over here is it true that the amount of money invested in the high risk account is twice as much as in the low risk account? Yes, that's true. I'm confident with my answer. Okay. So there's using systems or augmented matrices to solve word problems, applications, using systems of equations in applications. So that's 4 quick examples. We skipped number 4 just because in a video that's going to get kind of tangled. But notice that really the difficult part here, once I learn how to solve systems, particularly using the graphing calculator, very quickly I can just get the word problem into a system, use the augmented matrices to solve that system, and we're good to go.